Good morning all. In our last lecture, we have discussed about the Fourier series. Fourier series, it is applicable for periodic signal. In this video lecture, we will learn the Fourier transformation. Fourier transformation, it is applicable for the non-periodic signal. So in this curriculum, we have to study Fourier transformation both in the discrete domain and in the continuous domain. So in this video lecture, we will cover the discrete domain Fourier transformation. So look at this question. In this question, a one-dimensional input signal it is given to us, that is f of x is equals to 0, 1, 2, 1, and we have to compute its discrete Fourier transformation. So this question can be solved in two ways. One way it is called as the conventional method, another one it is called as the Tudor matrix format. So in this video lecture, we will cover the conventional method to obtain the discrete Fourier transformation for this given input signal. So the mathematical expression of one-dimensional discrete Fourier transformation it is given as f of u is equals to summation x equals to 0 to m minus 1 f of x e to the power minus j 2 pi ux by m. Now look at this question. In this question, f of x is equals to 0, 1, 2, 1. It consists of 4 points. So m in this case is equals to 4. So we will substitute m equals to 4 in this expression. So we will get the expression for f of u. F of u is equals to summation x equals to 0 to, in place of m we will substitute 4. So 4 minus 1 is equals to 3 f of x e to the power minus j 2 pi ux divided by 4. In place of m we will substitute 4, and on further simplification we will get this expression x equals to 0 summation x equals to 0 to 3 f of x e to the power minus j pi by 2 u into x. So since in our input signal there are 4 points 0, 1, 2, 1, so in our f of u, the DFT for this given input signal f of x, that is f of u, it also consists of 4 points. This point it is u equals to 0, it is u equals to 1, u equals to 2, and it is u equals to 3. So we have to compute f of u for u equals to 0, u equals to 1, u equals to 2, and u equals to 3. In this given input signal f of x 0, 1, 2, 1, this point it represents x equals to 0, this one represent x equals to 1, this 2 represent x equals to 2, and this one represent x equals to 3. So now we will compute f of u for u equals to 0, u equals to 1, u equals to 2, and u equals to 3. So first we will compute for f u equals to 0. So the expression of f of u that we obtained, it is summation x equals to 0 to 3 f of x e to the power minus j pi by 2 u into x. and f of x which is given to us, it is 0, 1, 2, 1. This point, it is our x equals to 0, it is x equals to 1, it is x equals to 2, and it is x equals to 3. So first we will compute for f u equals to 0, that is we will calculate f of 0. So in this equation, f of u summation x equals to 0 to 3 f of x e to the power minus j pi by 2 u into x. In place of u, we will substitute x. Sorry, in place of u, we will substitute 0. So the expression becomes summation x equals to 0 to 3 f of x e to the power minus j. In place of u, we will substitute 0, so it becomes 0. So from Euler equation, we know that e to the power minus j theta, it is equals to cos theta minus j sin theta. In place of theta, we will substitute 0. So it is e to the power minus j 0. So it is cos 0 minus j sin 0. From trigonometry, we know cos 0 it is equals to 1, whereas sin 0 is equals to 0. So e to the power minus j 0 we have obtained, it is equals to 1. So in place of e to the power minus j 0, here we will substitute 1. So the expression becomes summation x equals to 0 to 3 f of x into 1. Now we will open this summation for x equals to 0, for x equals to 1, for x equals to 2, and for x equals to 3. So our expression becomes for x equals to 0, here I will write f of 0. For x equals to 1, here I will write f of 1. For x equals to 2, here I will write f of 2. And for x equals to 3, here I will write f of 3. Now in the given input signal, f x equals to 0, that is f of 0, it is 0. So here I will write 0. F of 1, that is f x equals to 1, it is 1. F of 2, that is f of x at x equals to 2, it is 2. And f of 3, that is fx at x equals to 3, it is 1. So 1 plus 2 plus 1, it becomes 4. So we have obtained f of 0 is equals to 4. Next we will determine f u equals to 1. Next we will determine f u equals to 1, that is f of 1. In order to compute f of 1, in this expression, in place of u, we will substitute 1. So the expression becomes summation x equals to 0 to 3 f of x e to the power minus j pi by 2 into x. Now we will do the similar approach. We will open this summation for x equals to 0, for x equals to 1, for x equals to 2, and for x equals to 3. So first we will open this expression for x equals to 0. So it is f of 0 e to the power minus j0 plus f of 1 e to the power minus j. In place of x we will substitute 1, so it becomes pi by 2. Next, for x equals to 2, this is f of 2, and in place of x, if I substitute 2, it becomes e to the power minus j pi. Next, f of 3, in place of x, we have substitute 3, so it is f of 3. And here, if you substitute x equals to 3, it becomes e to the power minus j 3 pi by 2. Now, f0, that is fx equals to 0, it is 0. F of 1, that is fx equals to 1, it is 1. We have to compute the value e to the power minus j pi by 2. So we will use the similar Euler equation. e to the power minus j pi by 2, it is equals to cos pi by 2 minus j sin pi by 2. We all know that cos pi by 2 is 0, whereas sin pi by 2 is 1. So it becomes minus j. So in place of e to the power minus j pi by 2, I will substitute minus j. Now f of 2, that is fx at x equals to 2, it is 2, and e to the power minus j pi, e to the power minus j pi, it is equals to cos pi minus j sin pi. Cos pi is minus 1, whereas sin pi is equals to 0. So the expression we will obtain for e to the power minus j pi, it is minus 1. So in place of e to the power minus j pi, we will substitute minus 1 plus f of 3, that is fx at x equals to 3, it is 1. And we have to compute e to the power minus j 3 pi by 2, e to the power minus j 3 pi by 2, e to the power minus j 3 pi by 2, it is cos 3 pi by 2 minus j sin 3 pi by 2. We all know that cos 3 pi by 2 it is 0, whereas sin 3 pi by 2 it is minus 1. So it becomes 0 minus j multiplied with minus 1, it becomes j. So in place of e to the power minus j 3 pi by 2, we will substitute the expression j. Now on simplification, this minus j and plus j will cancel out. So the result is minus 2. So we have obtained f of 1 is equals to minus 2. Next we will compute f u is equals to 2. Next we will compute f u is equals to 2. For f u is equals to 2, that is f of 2. So in this equation, in this f of u equation, in place of u, we will substitute 2. So the expression is reduces to summation x equals to 0 to 3 f of x. In place of u, we will substitute 2. So the expression becomes e to the power minus j pi by 2 into 2 into x. On simplification, we obtain the expression as summation x equals to 0 to 3 f of x e to the power minus j pi x. We will apply the same approach. We will open the summation for x equals to 0, for x equals to 1, for x equals to 2, and for x equals to 3. So we will obtain the expression. First, for x equals to 0, it becomes f of 0 e to the power minus j0. Next, for x equals to 1, it becomes f of 1. And in this expression, if I substitute x is equals to 1, it becomes e to the power minus j pi. Next, for x equals to 2, it becomes f of 2. And in place of x, if I substitute 2, it becomes e to the power minus j 2 pi. Next, here I will substitute for x equals to 3, it becomes f of 3. And in place of this x, if I substitute 3, the expression becomes e to the power minus j 3 pi. Now we will substitute the values. F of 0, that is fx at x equals to 0, it is 0. So I will write here 0. F of 1, that is fx at x equals to 1, it is 1. And we have to compute the value e to the power minus j pi. So previously we have calculated e to the power minus j pi, it is equals to minus 1. So here I will substitute minus 1 plus f of 2, that is fx at x equals to 2, it is 2. Now we have to compute e to the power minus j 2 pi. So we will use the same Euler equation, e to the power minus j 2 pi, it is equals to cos 2 pi minus j sine 2 pi. So we all know that cos 2 pi it is equals to 1, whereas sine 2 pi it is equals to 0. So we have obtained the expression for e to the power minus j 2 pi, it is equals to 1. So here I will substitute it in, here I will substitute e to the power minus j 2 pi, that is equals to 1. Next f of 3, that is fx at x equals to 3, it is 1. And we have to compute this value e to the power minus j 3 pi. So e to the power minus j 3 pi, using the similar Euler equation, we will get the expression cos 3 pi minus j sine 3 pi. Cos 3 pi is equals to minus 1, whereas sine 3 pi is equals to 0. So we have obtained the expression for e to the power minus j 3 pi as minus 1. So here in place of e to the power minus j 3 pi, we will substitute minus 1. So it is minus 1 plus 2 minus 1. The resultant becomes equals to 0. So we have obtained our f of 2. It is equals to 0. Next we will compute f u is equals to 3. Next we will compute f u equals to 3, that is f of 3. So for f u equals to 3, in this expression, in place of u, we will substitute 3. So the expression becomes summation x equals to 0 to 3 f of x e to the power minus j pi by 2 into 3 into x. So we will apply the same method. We will open this summation for x equals to 0, for x equals to 1, for x equals to 2, and for x equals to 3. So one by one, for x equals to 0, this expression becomes f of 0 e to the power minus, in place of x, if you substitute 0, it becomes e to the power minus j0, plus for x equals to 1, this term becomes f of 1 e to the power minus j, in place of x, if you substitute 1, it becomes 3 pi by 2. Next, for x equals to 2, this term becomes f of 2 e to the power minus j. In place of x, if you substitute 2, this 2 and this 2 will cancel out, it becomes e to the power minus j 3 pi. And lastly, for x equals to 3, this term becomes f of 3 and e to the power minus j, in place of x, if you substitute 3, it becomes 9 pi by 2. Now we will substitute the values one by one. F of 0, that is fx at x equals to 0, it is equals to 0, plus f of 1, that is at x equals to, that is fx at x equals to 1, it is 1, e to the power minus j 3 pi by 2 e to the power minus j 3 pi by 2, we have earlier computed, it is equals to j. So here I will substitute in place of e to the power minus j 3 pi by 2, I will substitute j. Next, at f of 2, that is fx at x equals to 2, it is 2, e to the power minus j 3 pi e to the power minus j 3 pi, it is evaluated to be minus 1. So here in place of e to the power minus j 3 pi, I will substitute minus 1 plus f of 3, that is fx at x equals to 3, it is equals to 1. E to the power minus j 9 pi by 2 we have to compute. So for this we will apply the similar Euler equation. It is cos 9 pi by 2 minus j sine 9 pi by 2. So from trigonometry, cos 9 pi by 2 it is evaluated to be equals to 0 minus j sine 9 pi by 2 it is equals to 1. So the expression becomes minus j. So in place of e to the power minus j 9 pi by 2 we will substitute minus j. Now on simplification, this plus j and minus j will cancel out and we will obtain the value minus 2. So we have determined f u equals to 3, that is f of 3 is equals to minus 2. So now in summary, f u equals to 0, that is f of 0, we have obtained the value 4. F u equals to 1, that is f of 1, we have obtained the value minus 2. F u equals to 2, that is f of 2, we have obtained f of 2 is equals to 0. And f u equals to 3, that f of 3, we have obtained f of 3 is equals to minus 2. So for this given input, one-dimensional input signal f of x 0, 1, 2, 1, we have computed the one-dimensional Fourier transformation. We have computed the discrete domain one-dimensional Fourier transformation and we have obtained f of u is equals to 4 minus 2, 0 minus 2. So in this method we have converted f of x into f of u by using the conventional method. In our next video, we will convert f of x into f of u by using the Tudor matrix format. Thank you.